It is 1:59 UTC. So wait for it. I'm waiting. Tick, 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 tick. Dun, 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 dun. While you wait, dun, 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 dun. I just got a notification on my smartphone that I'm live. Bum, 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 bum. Dun, 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 dun. There we go. 2 hours UTC. Astronomy Daily Live is now live. I've already tweeted it. I'm going to go over to my smartphone and grab it on this so I can monitor all the shenanigans. So, hey everybody, hope everybody's doing well. Hope your past 20, 23-ish, 24-ish hours was well. Things are pretty good here. Um, getting warm. It is the Arizona spring. It has definitely sprung. So the two things that happen in at least southeastern Arizona in the spring is that the days get quite warm, probably in the 80s Fahrenheit. Quite cold at night though. Still probably getting into the high 30s, mid 30s, low 40s, something like that. So these huge swings and wind, just wind, um, almost like clockwork. Starts around noon and tends to die down as soon as the sun goes down. Now, wonder why. Wonder why that seems to happen. Don't know. It's one of those strange things that I'll bet you somebody has an explanation for. It probably isn't a good one. Who knows? Who knows? So yeah, I hope everybody's doing well. This is Astronomy Daily Live, and oh man, I have no, I have no drinks. I'm looking in my coffee mug; it's pretty much empty. My mug that usually holds either dihydrogen oxide or hydrogen hydroxide is not only empty but on its side. So woo, man. So I might have to exit just for a couple of seconds and fill that mug with the new uh, with the new batch of hydrogen hydroxide. So this is just a fun, casual get together, uh, circle of friends coming together every single day, sharing a passion for the science of astronomy, and uh, we can talk about pretty much anything here. If you've got questions, if you have answers, um, want to talk telescopes, CCDs, journals, want to talk about articles in Sky and Telescope magazine or Astronomy magazine, or what's the European one? I always forget what that one's called. Um, uh, but there's one over there. We can talk about spacecraft. We can talk about the moon. We can talk about astro-art, um, both visual art and audio art. Um, Literally, the sky is the limit. So yeah, I hope everybody's doing well. Just sort of letting everybody come in here who wants to come in here live before I really get going. I'm gonna uh, do um, a different kind of observing session tonight. Um, One of the things that I'm seeing in the analysis of my telescope and CCD system here behind me, sorry for the itchy nose, um, is that the the tracking is adequate for looking, and it's adequate for sort of short exposures. And what I mean by short exposures is 2 seconds, 2 seconds, maybe 3 second exposures. And that's all I can really do. Beyond that, the tracking isn't adequate enough to be able to keep, the same field of view on my CCD. So there are two things I can do about that. The first thing is more or less nothing, and just sort of say, okay, this is one of the limitations of my system at the moment. And, maybe it is, maybe it isn't. But the other option is to guide, is to somehow guide. So what that involves is, you know, pointing the telescope at your target and using a second CCD camera to focus in on a star somewhere in the same field of view. Now, the cool thing about the CCD camera that I have is that it actually does have two cameras on it. There's a science camera, which is the main camera, and then it has another, I assume a smaller, I don't even know the specs of that. I assume maybe a smaller camera that is called the auto guider camera, or the guide camera. And what this allows me to do, at least in theory, if everything was ideal, okay, if everything was ideal, then what I could do is I could set up a situation where I've got my main science camera on my target, and then I have this guide camera, as I said, looking at a star somewhere in the field. And what I can do is I can say, okay, system, I want you to keep that star on that pixel right there. And the way that it's going to do that is it's going to more or less constantly sample that smaller field of view with that star in it, right? And it's going to say, okay, I'm going to keep that star right there. And so what I'm going to do is when it seems to move off of that pixel in either X and or Y, I'm going to send a command to the telescope to counteract that, move a little bit, so it keeps that star right in that same spot. Now that would be called auto guiding. So it's sort of a feedback type of a thing. It sort of runs itself, and that's how when you look at a astrophoto of a long exposure of a galaxy, or something like that. That's what is being done. They either have a guide camera as part of their main camera, or they have a second telescope that has a camera on it that does the same thing. Now, in the situation that I'm in at the moment, I cannot auto guide because I have no means, at least at the moment, of commanding this telescope to move. The software and the computer that I'm using do not speak the language of this telescope. Now, there is some software and a little bit of hardware that I think I can get that will do that. So I'm looking into that at the moment. Um, Still have to install, the software. I have to make sure that it talks to my camera. Then I have to get this little interface device that goes from a USB to what's called an ST4 connector, which is the kind of connector that this telescope wants. And with that, that might all work. But in the meantime, what I'm going to try, and I'm going to try it sort of for the first time tonight, is I'm going to try to manually guide. Now, this is a challenging task, but you know, I think that it's a lot like most other things. Uh, you can learn how to do it. You learn how to drive a car. You learn how to ride a bike. You learn how to eat. You learn how to walk. You learn how to talk. You learn, right? You figure it out. So I'm thinking that I might, maybe at least in the short term, maybe in the long term. I mean, if I get really good at it, then it's like, uh, then then fine. Maybe I'll just do that. So tonight I'm going to set up my system. It's all I have to do is walk outside. Okay, and it's nice and dark. I've got a nice dark site here. And it's all I have to do is turn it on, turn the auto guider on, or actually the guider on, and see if I can learn to drive this thing. I need to be able to drive it really, really well. I need to be able to do it, you know, within a pixel or two. And so that's going to be moderately challenging, but I'm up for the task. And yeah, I think I might be able to do it. And if I can't, I sort of have plan B already in motion. I really there's really only two main things that I have to do, right? One, I have to install this software in order to talk to the camera and talk to the telescope. And then the other thing that I have to do is I have to buy this little interface box, which I mean is like it's this little tiny thing. It has a USB input on one side and an ST4, which is like a phone line or Ethernet line. It's skinny like a phone line, but it's got 6 wires on it. And so it's just this little box, right? That it just does the translation, right? And so the software, there's actually two pieces of software that'll run on the computer. The first one is the software that will talk to the camera itself and set exposure times, download images, blah 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 blah. And then there's another piece of software that actually does the guiding. So it'll talk to sort of the main piece of software, grab the guiding image. I'll tell that piece of software I want that star to be right there, and then via this main program, it'll send commands to the mount through this interface thing to make some small motions of the telescope mount in order to counteract the relatively poor tracking. So, but I'm going to try to do it manual first, it's I'm sort of an old-fashioned type in that way. Um, Manual guiding was how it was done for 100 years or so, maybe even a little bit more. So, if those guys and gals can do it for that long, then I think I probably can too. Probably can too. So I'm going to give that a shot tonight. It'll be the first time that I've ever done that. So it's probably going to be pretty messy, pretty disastrous. Um, but I think I'm going to learn a lot, and I'm going to know by the end of this evening whether I can drive this thing or not. So if I can, then I can do longer exposures, and longer exposures will improve my photometric, um, at least the photometric measurements. The astrometric ones, probably something like that. I do have um, some news in terms of the photometry. I finally finished um, my analysis of my first set of data that I took back on March 15th. Um, my evening of March 15th. It was actually March 16th UTC, and the seeing was pretty bad, and I knew that already. Tracking was pretty rough, so I could only do 2-second exposures. So I ended up having to write some software to both stack a series of images and also rotate them. So I shift, I rotate, and then I add, shift, rotate, add for um, all the images. And with 2-second exposures, I'm still sampling the seeing pretty harshly, pretty harshly. So I'm pretty sure I'm seeing that in the data. So, uh, but I did look at a star field in the vicinity of M41 and a star field in the vicinity of M46. And in both cases, my photometric accuracy is about 1/4 of a magnitude, and my precision is about the same. It's about 1/4 of a magnitude or so. So you know, given the pretty much fact that the seeing was pretty poor, and that the exposures that uh, I have to take are short, and so it's gonna be sensitive to seeing, um, because one of the things that seeing affects or seeing causes is this thing called scintillation. And scintillation uh, is the twinkling that you see of the stars. Um, so with a 2-second exposure, I'm definitely still seeing the twinkling, scintillation. Um, but if I'm able to guide, if I'm able to properly guide either manually or automatically, I can do a 1-minute exposure or a 2-minute exposure. And that's seeing, the scintillation sort of averages itself out. It's not going to be, it's not going to be as visible. So, um, so yeah, we'll see how that goes. I have another data set that I've just started looking at now, that I took on my evening of March 29th, the March 30th UTC, and the tracking with there was absolutely horrendous. But I have star fields of M46, M37, and M67. And I pretty sure that, well, I know for a fact that the seeing was different. The seeing was definitely different. Pretty sure, pretty sure that the seeing better, was better. So, you know, I'm pretty happy with a quarter magnitude accuracy with bad seeing and short exposures. I think that's pretty good. That's pretty good. Can't complain too much about that. If that's as good as I can get, if that's as good as I can get, I'm not too happy with that. Given the magnitudes of the stars and the brightnesses of the stars, that's about a 4 or 5% accuracy, which is it's okay. It's okay, but really for the project that I want to do, it's it's marginal. It's marginal. So as I said, I'm fairly certain that the seeing that night was pretty poor. It was probably almost as bad as it can get. So so if a quarter of a magnitude accuracy is as bad as it gets, then actually I'm pretty happy with that. So we'll see. We'll see. And as I said, tonight's task, spend a couple hours, a few hours out there. Um, I've I've got wind. It is clear, but I've got wind, so I didn't. I don't have to take any flats. I don't have to do anything like that. I'm not really taking any science data per se. I'm learning to drive, and I'm going to see if I can manually guide. Um, to at least a couple of pixels or so. I I don't know. I don't know. We'll see. We'll see. It's going to be a brand new thing. It's really like getting into a car for the first time, and it's like I have no idea. I have absolutely no idea. So yeah, as I said, I will continue to share this this adventure, this project with you. As I said, I do have an ultimate goal, which I'm keeping under wraps because it's you know if it turns out that I'm not able to um, do what I want to do, then then I don't want to get anybody excited. I don't want to get excited until I'm really sure. Um, Probably what I'm going to do next, depending on this new set of data that, as I said, I'm just starting to look at now. If that looks at least as good as what I'm seeing now, if not better, if it looks at least as good as that, then what I'm going to do is I'm going to make some observations of a variable star, probably an Algol like star. I cannot look at Algol right now because it is right next to the sun. It's up during the day, so I can't actually observe Algol at the moment. But there are many Algol-like stars, that have periods of a few days. They're called eclipsing binary stars, and so the actual um, uh, dimming event just lasts a few hours or so. And so, if the data that I'm going to be looking at, hopefully tomorrow, uh, is at least as good as what I've got now, then I'm going to move on to that um, variable star and see if I can catch that um, eclipse. So that'll be really fun and cool. And of course, I will share it with you as well. So I think what I'm going to do tonight, as I said, I'm changing the format of this live stream a little bit. We're going to be going a little bit shorter for a while. You know, my goal with this live stream, my daily goal is to get better and better and better every single day. And so I have to try things. I have to try new things. And so um, just I, I just want to cover a couple of things and then let you all go. Run for between 30 and 45 minutes or so, leaning towards the 30, because I greatly respect your time. I'm glad you come in either live or later. I'm getting a lot of views later, and that is very, very cool. So hello there, hello there. Glad you could stop in. Make sure to subscribe if you haven't already. Hit the thumbs up if you like this. Hit the thumbs down if you don't. I'm just interested in a reaction more than anything else. Not having any feedback at all. Um, uh, I'm just gonna, do my own thing. But if there's something that really bugs you, or if there's something that you really really like, let me know. Um, uh, because yeah, I want to get better. So I just want to make a quick plug for Ray Bradbury's The Martian Chronicles. Okay, if you folks haven't read The Martian Chronicles yet, you are missing out. So check check these. Um, this is a series of short stories, and they're all sort of related. They're all sort of related, um, and they're I mean, Ray Bradbury is awesome, right? I mean, he's just brilliant, brilliant. Um, One of my favorite stories in here is the second to last one, and it's called. Let me get it here. The interesting thing too is that this series of short stories covers a time period that goes from 1999 through 2026. Okay, so uh, when were these published? Let's see. So these were initially published in 1946, 46, 48, 49, 50, and 58. Okay, so but he he was writing science fiction about things in our time now. So it's kind of strange to read dates that are in sort of the modern era. The second to last story is called August 2026. There will come soft rains, and it's a really really good read, but a really awesome way to experience this particular short story is to go onto YouTube, okay, and type in, type in "There Will Come Soft Rains," Leonard Nimoy. Leonard Nimoy narrated this story, and it's awesome. It's absolutely fantastic. So highly recommended. Um, give a read, give a listen. Um, the Martian Chronicles. They're they're awesome. They're really 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 fantastic. If you like sci-fi, and I do, then get yourself a hold of a copy of the Martian Chronicles and give a listen to at least Leonard Nimoy's narration of "There Will Come Soft Rains." It's awesome. It's absolutely fantastic. So hey, let's let's do A horoscope? No, I don't really know anything about that at all, Ray Brown, at all. Yeah, sorry, I don't know anything about that at all. I'm doing astronomy here, the science of astronomy, where we talk about, telescopes and observing and the motion of the planets around the sun, galaxies, stars, how stars evolve. We can talk about the universe. We can talk about atoms. My horoscopes, I'm I'm the wrong source for that. But hang around, because what we're going to do right now is what's called uh, the Astronomy Daily Live object of the day. Object of the day. And what I'm going to do is I'm going to randomly choose a Messier object. So there's 110 of these. They were discovered and cataloged by a French astronomer back in the 18th century, uh, named Charles Messier. He was a comet hunter, and so he was looking for little faint, fuzzy things that moved, because that's what comets do, right? Comets orbit the sun, and relative to Earth, they move quite a bit. Even over the course of a day, you can see them moving. Well, comet hunters look all over the sky for new comets. And so Charles Messier, in his viewing of the entire sky, came across these things, didn't know what they were, but they didn't move. They didn't move. So he's like, well, I don't think these are comets because they're not moving, but uh, who really cares, right? They're not comets. I'll write them down. I'll write the positions down, and it'll be a list of objects to avoid, right? So when he or the other comet hunters, would come across one of these, they would look in this catalog and say, "Oh, no, that's not a comet. Move on," right? Well, it turns out that these objects were galaxies, um, open clusters, globular clusters, planetary nebulae, and gaseous nebulae, non-stellar objects, things that aren't stars, definitely aren't comets, not even part of the solar system, and in the case of galaxies, not even part of the Milky Way galaxy, right? They're beyond the Milky Way galaxy. So he found 110 of these. So let's go look at one of them, and I'm going to share my screen. Maybe this poor little laptop is struggling a little bit tonight. Struggling. All right, here we go. So let's go over to random.org and have the internet's famous random number generator choose a number between 1 and 110. And with the Messier objects, I like to, once we have the number generated, I like to try to remember which, what what object this is, because at one time, at least, I was pretty familiar with all of the Messier objects. I've done the Messier marathon several times. That's when you can observe all but one of the objects in a single night. So that's kind of fun. But yeah, let's have random.org pick our Messier object of the day. So drum roll, please. Boing. M13. Haha. Okay, this one's a famous one. Uh, almost every astronomer knows M13. This is a beautiful, beautiful, gorgeous, huge, bright, globular cluster in the constellation of Hercules. And in a dark sky, in a very, very dark sky, you can see it with your naked eyes. You don't need binoculars, you don't need a telescope. Now, it looks pretty small, right? Because you don't have any kind of magnification or anything like that. And you can't really see a lot of details, but you can definitely tell that there's a fuzzy fuzz there in the constellation of um, Hercules. Now, M92 is also a Messier object in the constellation of Hercules, and it's also a globular cluster. But let's look at M13. Now, it's a fact that there's going to be a lot of information about M13. So let's go to Simbad. There's going to be a lot of papers. There's going to be a lot of names. There's going to be a lot of information on M13. M13 is a very much studied, well-known object. So there's a zoomed in picture of it. You can see that the center of it is overexposed. Now we'll come back to that. Let's look um, at the characteristics and position of this globular cluster. So the right ascension is at 16 hours, 41 minutes, 41.634 seconds. And the declination is positive 36 degrees, 27 minutes, 40.75 seconds. It looks like it's moving towards us at a velocity of 246.6 kilometers per second. And it's relatively big, right? It's almost 8 arc minutes in diameter. So that's pretty big. That's sort of why it's hard to see naked eye, because that's still pretty small. I think our eyes can resolve things down to about maybe 2 or 3 arc minutes or so under best conditions. So this is 4 times that size. So we can definitely see it. So the V magnitude, which is sort of a visible light magnitude, is 5.8. J, H, and K, those are towards the infrared, and you can see they're pretty bright. It's getting pretty bright. The magnitude scale in astronomy is opposite what you sort of think. So the larger the number, the fainter the object is. So yeah, it's just one of those weird things that you have to get used to if you get into astronomy at all. So let's see. Wikipedia has a nice picture of that. Yeah, I prefer. M13 is one of those objects that I love to look at through a telescope, because you can see all the way down into the center of the cluster, and it's there. You can see structure. You can see patterns in the stars. It's really awesome. Now and maybe we can find out a little bit of information about this, but there's roughly 500,000 stars in this globular cluster. They're all very, very well, not all of them, but many of them are very, very old. Well, I guess you can say all of them are old. Now, not all of them are red. Some of them are actually blue. Those are called blue stragglers. And the theory is that these red giant stars, these old red giant stars, have actually merged and added their masses together, which heated them up and turned them blue or yellow or something else, right? So more or less, as far as the theory goes, it's the same age, but you've got mostly red stars, but you've got some yellow stars, some blue stars. Yeah, so very, very cool. Let's see. So as you probably saw, yeah, there's a lot of references to this object, lots of papers, lots and lots of PhDs, right? Lots of master's degrees, lots and lots and lots of work has been done uh, on this object. Huge. There's almost 2,000 references here. Just insane, right? Just absolutely insane. Let's see how far away it is. Mm, Come on. Display all measurements. Sorry about that. So 0.008 megaparsecs. I don't know why they put things in megaparsecs. That's millions of parsecs. So a parsec is 3.26 light years. A megaparsec is 3.26 million light years, which 10 to the sixth. And then you got to multiply that by 0.008, 0.008, and you get about 26,000 light years away. So M13 is about as far away from us as the center of the galaxy. And in fact, most of the globular clusters, in fact, I think I can say pretty surely that all of the globular clusters tend to sort of group around sort of near the center of the galaxy. Now, M13 is sort of an outlier. It's not extremely close, but but it is at least as far away from us as the center of the galaxy. But it's sort of off in a different direction. I don't know what these observing logs are. Let's see what that is. I don't know. I'm not seeing anything there. Hmm. Have to get into this stuff a little bit more to really understand what all this information is, because I think it's interesting and useful. I just don't know what it is, and so I can't talk about it. It's a bummer. Let's go over to Ned, see what if Ned has anything interesting to say about M13. It's probably about the same basic information. Magnitude 3.887. Definitely pretty darn bright. Say that much. All right, let's take a quick look at the picture. One of the other things that I like about M13 is that right next to it is a nice little galaxy. Now, of course, that galaxy is in the background. It's way, way, way in the background. But I always like to see that. I think that's NGC 6207, if I remember right, because M13 is NGC 6205. So there it is, M13. Look at all those stars. Look at them all. You can't even tell that they're stars because it's so washed out. Just amazing. There it is. So here's NGC 6207 right there. And M13 is right sort of between these two stars here. Isn't that cool? A very popular, well-known globular cluster. I think there's over 200 um, known globular clusters. If memory serves, something like that. Here where I'm zooming way, way, way out, you can actually see part of the constellation of Hercules. This pattern of 4 stars here is called the keystone. And you can see that in the sky really relatively easily. And so in order to get on to M13 with your scope, at least what I do is I just draw a straight line between these 2 stars, and I go about a third of the way towards that star, and M13 just pops right in, just like that. So a nice, beautiful globular. Very, very awesome. Let's, since Tom mentioned the Wikipedia image, let's go over there and take a look. Oh yeah, yeah, yeah. See, this is so much nicer because you can see all the way into the center, and that's nice. And here you can also see some color as well, right? But as you can see, a lot of these stars are, just sort of small and dull and everything else. But then you've also got these blue stars. We can zoom in here. We've got these blue stars. We've got these orange stars. We've got these yellow stars. Look at them all. Isn't that amazing? Can you imagine living on a planet around one of these stars? I mean, what does your sky look like? Do you have a night? I don't know. I don't know. I mean, uh, we could probably figure out or find out, like how far across this is, right? How many light years across this is, and we could get a pretty good estimate as to how many stars are in here. And knowing those 2 pieces of information, of course, um, we could make a pretty good guess as to how far apart on average the stars are. But I can't imagine that they're too far apart, right? They got to be really, really close. So living on a planet inside of a globular cluster, ooh, I don't think there's any nighttime. Hard to see out too, right? Because there's so much stuff. Yeah, so much stuff. All right, well, cool. I am going to end this live stream for today. We've gone 47 minutes already, which is a little bit past what I want to be doing for now. So yeah, M13 popped up on random.org. Um, I think every astronomer knows M13. If you've never seen it through a telescope, definitely, 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 it's up there with Saturn, right? Saturn is mind blowing, right? When you first see Saturn through a scope, that's like life changing, right? Well, M13 is like that too. It's absolutely astonishing, especially in the nice dark sky. Uh, yeah, really, really, really nice. Um, Much studied, well studied. I didn't even get into the references here. Thousands and thousands of papers, PhDs, years and years and years of work. Um, with those guys. Anyway, I'm going to get out of here for now. Peace, cheers. I'm going to go outside. I'm going to learn how to drive this thing. We'll see. We'll see. If I can manually guide, then I'll be a pretty happy camper. So, but I think it's going to take a little bit of practice, a little bit of, yeah, just uh, some practice. Yeah, yeah. All right, I'm going to get out there. I'm going to let you all go. Thanks for coming in. Check me out tomorrow, 23-ish hours from now. We will be back. Join the circle, subscribe, hit the like, hit the don't like, whatever, whatever. Make some comments, suggestions, share this video around with people who you think might also enjoy this kind of content, this kind of fun, casual get together. No, no, no real topics or anything at all. It's just, whatever we want to talk about. We want to uh, share the passion for astronomy. So, all right, peace out. I will see you tomorrow. All right, bye.